Hi, and welcome to the second session in today's event. My name is Jordan Marshall, and I'm the Chief Reporter at Building Magazine. Today is our first event in our Buildings Design and Specification program, and it's all about materials. This session particularly is centered on innovation in materials, and more specifically, how to prevent brick stain and efflorescence. This afternoon, I'm joined by Matthew Davies, who's National Specification Manager from Van der Sanden. We're just having a few technical difficulties. So at the moment, Matt is here, but he's here with his camera off. I promise you, it's not just me. And so he's going to talk us through all the key points before answering all your questions in the Q&A session. So please feel free to send those through at any point. Before I hand over to Matt, who is going to talk us through all the key points and topics at hand, I just wanted to flag there are a couple of very short videos that play with sound. If for any reason you can't hear them, then there's an option to adjust your audio in the bottom of your screen to another output. Otherwise, they are quite short. Please do bear with us, and the sound will resume again as soon as Matthew begins speaking. Without further ado, I'll turn off my mic and my camera, and I'll hand over to you, Matthew.
Thank you, Jordan. And again, apologies for not being able to see me for this seminar. So yeah, my name's Matthew Davies, and I'm the National Specification Manager here at Van der Sanden, where I'm responsible for the sales strategies around enhancing our specification offering here in the UK. So yeah, if you could just sort of keep any questions and that for the end. I think we've got the Q&A section planned with Jordan. So yeah, the plan for this is it's one of our shorter seminars. It lasts around sort of 30-35 minutes. And yeah, we've got that Q&A section at the end, and it is just one of our sort of CPD seminars that we have in our Inspiration series. So please head over to our website if you'd like to see what other offerings we have. Okay, so Van der Sanden are the largest family-owned brick manufacturer in Europe. And we've got that passion for creating fantastic looking facades. So we have a proud pedigree dating back to 1925 and are highly respected within the industry for our innovation and solution-driven approach. So we operate from 14 locations across Europe, employing over 725 employees and producing a wide range of clay pavers and facing bricks. So we're firm believers in collaboration throughout the industry, and we really do believe that together we can build greatness. So as a family-owned business, we pride ourselves on our core brand values of craftsmanship, innovation, sustainability, integrity, and being people-orientated. So these in turn correlate with our mission of being that partner that designers turn to when they want to create those innovative yet beautiful facades and streets. So we really are driven by what our customers require now and in the future. And it's vitally important to us that we continue to innovate sustainable products and solutions that will enhance the built environment for those future generations. So I'm just going to show you a bit of an insight into our sustainability focus here at Van der Sanden and how we see the future of brick with a short video clip from our CEO.
In zijn huidige vorm heeft onze traditionele baksteen nog slechts een eindige toekomst. Maar in zijn nieuw kleedje blijft hij bestaan voor de eeuwigheid. In onze samenleving is duurzaamheid meer en meer belangrijk. Daarom zullen we ook onze productie van de bakstenen duurzamer en energiezuiniger moeten maken. Dat is de uitdaging waar wij voor staan en waar wij volop voor gaan. Om een duurzamere baksteen te produceren zijn er verschillende manieren. De eerste manier is om deze gevelsteen van 10 cm breedte te gaan afslanken tot 7 cm. Kun je nog normaal mee metselen of verlijmen, dat is beter. En dan spaar je 30% uit aan materiaal en aan energie. Maar de revolutie is de transitie naar baksteenstrips van 1,5 centimeter. Dan bespaar je meer dan 80% aan materiaal en ook meer dan 80% aan energie. Dit wordt de gevelsteen van de toekomst. Op een duurzame manier, ecologisch geproduceerd. De doelstelling is om tegen 2050, zoals opgelegd door Europa in haar Green Deal, bakstenen te produceren op een groene, CO2-neutrale manier. De betere manier is zero emission, geen CO2-uitstoot, door zowel te produceren, te drogen en te bakken met groene stroom afkomstig van zonne-energie en van wind. Maar we willen nog een stap verder gaan dan zero emission. In plaats van geen CO2 uit te stoten in de productie, is Van der Zande bezig met de ontwikkeling van een gevelsteen die CO2 opneemt. Sterk, disruptief. Dat is de toekomst. Als familiebedrijf denkt Van der Zanden in generaties. Door al deze transities van steen naar strip, van CO2-uitstoot naar CO2-opname, zorgt Van der Zanden voor een beter leefmilieu, zodat onze kinderen en kleinkinderen bouwstenen hebben voor een betere samenleving.
Okay, so we're going to just look at what we're covering in this CPD. So we're going to be starting off and exploring some of those discolorations issues that are experienced in brickwork before delving into a bit more detail and discussing the different types of stains and the science behind them. And finally, we'll finish off with some preventative methods and ways that we can design in some protection just to help avoid these stains from happening. Okay, so there are several types of stains that can be seen or experienced in brickwork, and these usually vary in colour depending upon the brick type and stain. However, this CPD focuses on efflorescence and gypsum that are usually expressed as that white discoloration on a facade. Okay, so there have been years of research into these types of white discoloration experienced in clay brickwork, with various publications released into the causes. The most recent doctoral study by the University of KU Leuven in the Netherlands largely attributes these stains to the joint mortars used and classifies the stains into sort of three categories. So mortars have evolved over time to sort of have extra plasticity, adaptive curing times, and cost reduction. And unfortunately, the effects of these substances are not usually discovered until some time after the construction and the bricks start to sort of change colour. So there are three types of stains which fall into two categories. We start off with primary efflorescence, which is salt efflorescence and lime efflorescence. And then in the second group, we've got secondary efflorescence, which is mainly gypsum efflorescence. And it's these three stains that we're going to be looking at in a bit more detail now. So how do brick stains and discolorations usually occur in brickwork? So it usually starts when the facade or the individual brick gets wet by the rain. So as some bricks, those typically with more open pore structures, such as stock bricks, they're a little bit like sponges and they absorb water through the pores through a suction effect. So in addition to water, they can absorb additional minerals such as lime and salts. So as the brick starts to dry out, water evaporates through the brick face, and these minerals then deposit themselves on the face of the brick and are usually visible as this white discoloration. So the effects of nature and society can also impact upon the colour of the facade, where additional dirt deposits attach themselves to the bricks, particularly in wet conditions. So as we'll be able to see in this video, when it rains, a brick absorbs water into its pores, and a brick also absorbs water from the mortar, and minerals and small gypsum particles dissolve in the water, which are then transported through the brick pores. So once the facade starts to dry, the water evaporates, drawing these minerals to the face of the brick, where they become visible as this white substance or discoloration. So let's start by looking at our first stain, primary efflorescence, salt efflorescence. So salt efflorescence is visible in the early stages of construction, usually when the scaffold is being struck, and you can start to see the full extent of it. So it's mostly common on newly constructed brickwork, and this can be for several reasons. So the first reason can be the salt content found in the clay used to make the brick. And the primary salts involved here are all water soluble. So this means that they turn into a solution as soon as water reaches them, whether that be from the mortar or the brick, wherever they may be present. So the most common salts are sulfates of sodium, occasionally potassium and magnesium too. And it's also thought that nitrates or phosphates are also known to be possible sources of efflorescence, but some research suggests this is seldom the case. So research shows that calcium oxide from the mortar will react with the water to build calcium hydroxide, and this is extremely water soluble. So if the freshly built wall is not covered and water runs over and through it, this can result in efflorescences. So primary efflorescence is more visible on the bricks as a result, and usually appears on the facades towards the end of the winter and the beginning of the spring as that masonry structure starts to dry out and the salts become expressed. So how do you prevent primary efflorescence and salt efflorescence? So firstly, we need to make sure you're following the manufacturer's advice and using the correct mortar for the type of construction. But in the main, you want to be protecting the bricks and mortar from excess water and using wall covers where possible to add some additional protection. So after construction, you want to be keeping the masonry as dry as possible, ideally up to around 10 days, whilst promoting some effective ventilation of the cavity to promote some drying. So the treatment for primary efflorescence, salt efflorescence. So as this is a transitionary phase, it usually weathers away naturally after a couple of showers and dry periods. But some other remedies that you can use to speed the process up are using a dry, soft bristle brush, sort of a dustpan and brush, to brush and collect the salts into the pan. Basically allowing them to fall to the ground could result in them being reabsorbed into the ground and then the brickwork. And you can also use a clean wet sponge to draw out some of the excess minerals from the body of the brick. So primary efflorescence, lime efflorescence, or lime runoff, as it's also described, usually happens on the mortar joints and can then travel down the face of the brick, as we can see in this image. So how does it happen? So in order to establish some adhesion between the bricks and mortar, excess lime is created that reacts with the carbon dioxide in the atmosphere. So particularly under wet conditions, the brick pores can overflow, and this carbonation process required to achieve adhesion between bricks and mortar is a lot less effective. So as a result, excess lime is created and expressed out onto the brick facade. So let's have a look at the carbonation process and understand how this can impact upon the severity of the stain. So under good conditions, carbon dioxide from the air converts this excess lime in the mortar into a non-water soluble lime and cures. However, under adverse conditions, calcium oxide from the mortar will react with the water to build calcium hydroxide. And this is extremely water soluble, and this spreads then throughout the masonry structure. The calcium hydroxide then reacts with the CO2 from the air to form the water-insoluble calcium carbonate, lime, and this is what we then see expressed out on the facade. So at an early stage, lime efflorescence or lime runoff, calcium carbonate can be removed very easily using water or brick cleaner. But if it is left, it will have to be professionally removed with special cleaning products. So rain and too much moisture are the main issues here, but it's important to note how important that carbonation process is to ensure the adhesion between bricks and mortar. So this image just shows some lime efflorescence on a completed facade. And we'll now move on to our secondary stain or secondary efflorescence, gypsum efflorescence. So it's different to primary efflorescence in that it appears much later in the building's lifespan and can really have considerable aesthetic implications. So secondary efflorescence, gypsum efflorescence, is usually a white-grey, semi-transparent discoloration that appears months or even several years after the construction has been completed. So it's normally visible on that southwest elevation of a building, and due to its grey colour, it's more visible on the brick than on the mortar joints. So unfortunately, as a stain, it's very stubborn and not soluble in water or acid, and in the majority of cases can be attributed to gypsum that we're going to be covering next. So this image just shows the secondary efflorescence, gypsum efflorescence, and the impact that it can have across a whole building. So yeah, gypsum, we'll talk about that now. So gypsum is actually added to cement as an auxiliary substance just to help with the curing. So due to the effect that carbon dioxide has on mortar, it tends to cause excess gypsum to be released from the cement. So the additives in the mortar then transport the gypsum into the brick pores, where it then crystallizes. So rain and wet conditions stimulate this process, and it usually happens when an uncompleted brick facade is left exposed to the rain, followed by very quickly by heat from the sun, causing the gypsum to crystallize in the brick pores. So this image here, we can just see how the top of the building would have been left exposed to the rain and then dried out again, and we're seeing that gypsum efflorescence. So the consequences of these types of stains are certainly more than just aesthetic. So architects are less likely to want to showcase and promote their projects if these stains are prevalent. Contractors are likely to receive questions and complaints from clients and architects around the causes and costs of remedial work to put it right. So owners of the property are less likely to be proud of their home, and as a result, it could be lower house prices if that aesthetic there is still there when they're selling the property. And big question, how significant is the problem? So it's actually existed for around 20 to 30 years, and this is thought to coincide with the changes in mortars to make them more pliable. So as a result, research suggests that 80 to 85% of facades that have been built across Europe in the last 15 years are suffering from these types of stains in one way or another. So it's only those bricks with low water absorption rates that are less affected, but this only equates to around 10 to 15% of all brick facades. So how can we prevent these stains and help design in some protection for the facade? So we can start by ensuring that we provide a design which is easily achievable in practice, and ensuring that any details are detailed correctly to avoid any backwards and forward discussions that may result in parts of the facade becoming saturated by rain. So by detailing brickwork to ensure the maximum shedding of water in service is very important, as avoiding saturating parts of the facade will encourage the transport of water-soluble minerals throughout the building. So the storage of bricks on site and under cover is to prevent additional saturation from the rain and prevent any minerals from the ground being absorbed into the bricks that then may be expressed later. But the main thing here is that all help to avoid saturation of brickwork during and after construction will limit the effects of efflorescence and these other stains that are experienced within brickwork. So there are other ways that we can add some protection to a brick facade, and one is to apply a protective treatment after the structure has been completed. So this would usually be undertaken on site by a specialist contractor and would need to be undertaken in a timely manner, ensuring that the facade has been cleaned thoroughly whilst also giving it time to dry. So it's worth noting that when choosing this coating option, we recommend that you discuss the detail of the application method and the coating being used with the contractor or manufacturer as early as possible prior to construction, as it's essential that you confirm at this stage that any coating being applied won't adversely affect the fire performance of the brick. So the preparation work, coating performance and coverage, and also application timings and any environmental impact should all be discussed and considered at this stage, ensuring that the coating selected is provided by a reputable manufacturer who complies with the relevant UK building product standards. So as of recent innovation, brick manufacturers are investing in specific coating facilities whereby bricks and brick slips are coated as part of the production process. So as we can see in this video, the coating is mechanically applied to the brick or brick slip in the factory, and this provides a number of benefits and ensures that a consistent coating is achieved prior to delivery on site, saving time and cost during construction. So the coating applied in this process shown here is a silane silaxane, which is a low VOC coating, and as such is benign with no impact on health and safety or the environment. So how do coated bricks work? So we're just going to have a look now at how the coated bricks work and how they could help you as a specifier design in some extra protection to your facade. So the application of a water repellent layer to the faces of a brick that penetrates up to 10 millimeters into the pores is a solution that could be incorporated into the manufacturing process. So to understand how the water repellent layer works, it's important to understand the pore structure of a brick. So if we start by looking at the capillary action of a traditional brick, you can see how the brick pore acts similarly to a sponge and sucks up the water that is then transported into the body of the brick. So when a brick is coated during production, the pores of the brick can be coated with consistency, which ensures that the main faces of the brick become water repellent, while still allowing the brick to breathe, just like a Gore-Tex raincoat. So silane or silaxane are chemical side strings combined with elements to form different lengths. And depending on the length, these strings will then penetrate the pores of the brick to various depths, providing better water retention, repellency, whilst keeping the pores of the brick open, enabling it to perform as it should from a durability perspective. It's also worth noting that whilst it adds extra protection against those water-soluble stains that we've discussed previously. So the type of coating here is a silicon water-based, environmentally friendly product with a low VOC rating and is UV resistant. And the coated brick can be handled for construction in the usual way once it's been delivered on site, and any unused bricks can be stored and recycled in the usual way. So it's worth noting that under test conditions, when silane silaxane is applied to bricks, its combustible nature and emitted carbon whilst burning is 0.04%, and that is exactly the same as an uncoated brick, which is classified as A1 non-combustible. So the adhesion with the mortar joint, so in some cases where poor quality mortar is used, some research sort of shows that bricks can absorb more water from the mortar, reducing its strength. So coated bricks, however, do not allow for water to be absorbed into the brick, promoting a stronger bond on the edges that are coated. So coated bricks are available in a range of colours, from the more traditional reds and buffs to those more contemporary in vogue greys, whites and blacks, which may be a bit more susceptible to the effects of efflorescence and staining. So the coating applied in this option is transparent, with no adverse change to the visual aesthetic of the brick. In fact, the coating will usually enhance the natural colour and beauty of the brick. So the benefits of coating your facade are that it keeps the facade looking as it should for longer, whilst blocking those water-soluble salts, lime and gypsum from being expressed. However, you should also consider long-term performance and suitability for any coating in application and discuss this with the chosen manufacturer before the coating is applied. For example, will the brickwork need to be recoated in the future? If so, when? What guarantee of performance will be provided and for how long? And how will the coating perform if masonry paint is subsequently applied? So the benefits of using coated bricks in your facade are that it keeps the facade looking as it should for longer, whilst blocking those water-soluble salts, lime and gypsum from being expressed. So coated bricks also stay drier, meaning the facade will attract fewer dirt deposits, whilst keeping the pores of the brick open to perform as required, enhancing that mortar adhesion as a result. So depending on the manufacturer, coated bricks are available with up to a 25-year performance guarantee against gypsum efflorescence at no additional cost, but we recommend you confirm this with the manufacturer early in the specification process. Product application and usage. So coated bricks have been designed to add additional protection and prevent unsightly stains appearing across your facade during and after construction, whilst continuing to promote skilled labour, quality workmanship, and the required building standards expected when building with brick. So coated bricks are designed to enhance environments and are ideal for any residential or commercial construction projects where the brick facade will be highly visible and exposed to the elements or pollution. So from a building design perspective, if you're considering using brick colours which may be more susceptible to showing the effects of efflorescence or staining, for example, those deep reds, greys or blacks, then coated bricks really help provide that perfect alternative to a standard uncoated brick that is coated after production. as these will save time and money during the construction phase and beyond in terms of restorative and remedial work. So the only difference you're going to see as designers and specifiers is this beautiful long-lasting facade. So compliance and adherence to industry standards is essential when selecting bricks and any coatings being applied. So all products must comply with the current standards as defined by the British Standards Institution, who are the UK body that ensure that products are assessed and approved for use. So certification standards for clay bricks in the UK are BSEN 771 Part 1, that's a specification of clay masonry units, and the Eco Standards ISO 14001. So with the other recognised standards which must be followed are BS 8000 Part 3, PD 6697, and PAS 70, Public Available Specification 70. So here's just a short video clip of just to recap the content that we have talked about in this CPD today.
In the last 20 years, a series of improvements have made mortars quicker and easier to handle. One impact of these changes is the increasing visibility of efflorescence on facades. Efflorescence is caused by a number of factors, where water plays an important role in addition to the mortar. How does efflorescence occur? When it rains, a brick absorbs water into its pores. A brick also absorbs moisture from wet mortar. Minerals and small gypsum particles dissolve in the water and are transported through the brick pores. When the brick dries, water evaporates through the face of the brick, with minerals and gypsum particles deposited on the surface. Types of efflorescence. There are 3 types of efflorescence. Early or primary efflorescence is either salt efflorescence or lime efflorescence. The third type is secondary efflorescence, also known as gypsum efflorescence. Early efflorescence of salt and lime is often seen in the spring, as the masonry structure starts to dry out and the salts are expressed. Salt efflorescence. Salt efflorescence occurs shortly after bricklaying has been completed. Possible causes include the use of excessively wet mortar, saturated bricks, or the failure to cover the newly built masonry properly when it rains. This efflorescence typically disappears over time because rain dissolves the salts and washes them away. You can also brush the facade carefully with a soft bristle brush to remove it. Salt efflorescence can be prevented by keeping newly built masonry dry. Lime efflorescence. Lime efflorescence can occur when there is excess moisture within newly built masonry. Mortar hardens best by reacting with CO2 in the air. It is important that the facade is dry for the best curing. As long as the lime in the mortar has not fully reacted with CO2, there is a chance that the free lime will dissolve due to saturation of the facade. When the facade dries, the water evaporates through the masonry face, depositing free lime onto the face of the brick, which then hardens through the reaction with CO2 in the air. This type of efflorescence can be removed with acid-based cleaners. Again, make sure you prevent lime efflorescence by keeping newly built masonry dry. Gypsum or late efflorescence. Gypsum is a complex phenomenon. It is caused by an interplay of various processes in the masonry, which cause gypsum to form and be transported to the surface of the brick. This process is very slow. It may take several months or even years before this grey deposit becomes visible on the brick. The phenomenon is most common on elevations exposed to rain. Its effect can be reduced by overhanging eaves, offering protection. Gypsum is a persistent type of efflorescence that can only be removed by sandblasting the facade.
Okay, so just to recap what was covered in this seminar, we started out exploring the issues of brick staining before looking at the different types and discussing some of the science behind how they develop. And we finished off looking at how they can be prevented and considered new ways of designing in some protection. So I'd now like to hand back to Jordan to pick any questions. I don't know if you want me to attempt to put my camera on or not, Jordan.
I think, but maybe let's play it safe so we don't lose you, because you're the expert.
Yeah.
There's no point me putting the audience's questions to me. So I think maybe it's best. The first question that I have to ask, just because it's a big topic that's we've already covered in our earlier session today, but is one that is a hot topic across the sector. And that is, how is Van der Sanden currently affected by the material shortage in UK building and construction? Just, you know, particularly with these innovations, but more generally as well.
Yeah, I mean, we're certainly, like everyone in the industry at the moment, experiencing it, and we're kind of doing our best really to work with our strategic partners to enhance our sort of supply chains and make sure that we're still able to provide customers and those sites that we've got specified. So yeah, it's certainly a challenging time, but we're certainly doing what we can at the moment to ensure we're looking after those that look after us, that's probably best to say.
Brilliant. And I just wanted to say to our audience again, please feel free to send through some more questions. We have some coming through, but we want to cover off as many of the things that you want to know as possible. So we have one question here that's asking, are there any specific brick materials that are more susceptible to efflorescence than others?
Typically, you're going to, like a stock brick or a hand formed brick is going to be more susceptible to efflorescence than say something like a wire cut brick. And that's purely down to the production method. Stock bricks tend to have a lot more of an open pore structure, whereas a wire cut brick tends to have quite a, I suppose, like a soft closed structure. And yeah, they don't actually absorb as much water as I suppose a stock brick's going to.
Okay, brilliant. So then another one in sort of like a big picture scene is how sustainable, because obviously CO2 and the push for net zero is really big in the built environment at the moment, and it was something that you've covered off in your presentation. But just how sustainable is the Van der Sanden solution for efflorescence?
Yeah, so in terms of sustainability for brick, the coating itself is there to try and make the industry more sustainable and try and promote effective brick architecture. But we are working on other ways to try and get to that carbon neutral and arguably a negative, as we saw in the video from our CEO, where we're looking at developing some carbon negative bricks at the moment, which I certainly feel is going to be an innovation that could change the whole sector if once we can finally bottom out a few things in relation to that.
Brilliant. We've had another question coming in here. Does it depend on the quality of the brick, i.e. the more expensive the brick, the better performing it will be, or are there other factors that should be taken into account?
It's a very good question. Not necessarily the case. Again, as we adhered to in the presentation, a lot of it can be a case of excess water within the building construction element. So even if a really good quality brick that you might be paying nearly £2-3 for, if I suppose there's a high level of water content, the likelihood is you're still going to experience some efflorescence as a result, just the way it's transported into the brick. Okay,
brilliant. So one thing that our audience always really loves is, practical examples. And I know we've highlighted a couple of Van der Sanden projects where Van der Sanden's products have been used in our live blog today. But is there any recent or current projects that you can explain how they've been, where the product has been used and how that's sort of gone?
Yeah, so we've got quite a large scheme down in Brighton, which uses our Perla brick, which is one of our white bricks. And again, that was selected for that scheme just on the basis of the coating being applied and the fact that it's not going to attract any additional dirt deposits as a result. So that's probably a really good one. That was done by Boyce, and I think there's an aerial flyover actually on social media that people can view for that. We've got a couple of other projects, but I suppose the main thing is that any specified Van der Sanden brick from now on is going to be coated if it's coming from our hand form range. So yeah, it's worth double checking with us before, just to make sure you're maximising that coating.
Okay, we've had another question coming through about how will pre or post treated brickwork react to graffiti and graffiti removal?
Yeah, it's always worth discussing that sort of thing with the graffiti I'm trying to think what they are now, like the sprays that you put on those specific manufacturers. We don't really get involved too much with the graffiti element, but from my experience, it is a spray that is applied, an anti-graffiti spray that is applied to a facade, and then once it's actually had graffiti, when you're clearing it off, that is actually then removed at the same time. So I presume that's going to have a similar sort of impact with any other coating. It's just probably worth checking that these coatings that are applied once the facade is completed, that is it going to remove that at the same time as it's removing the anti-graffiti?
Brilliant. So then another question that we have here is about how do coated bricks react with hydraulic lime plaster, and are they compatible?
Yeah, they're working exactly the same way, and the big thing about that is we're going to obviously increase that circularity aspect of a brick as well, and the recyclability nature of it. I mean, bricks that use lime mortars tend to be a lot easier to recycle than, say, these modern day mortars.
Well, the questions are all flowing in, but like I do want to let everyone know we want to try and get through as many as possible, so please keep sending them through. One from me quickly, just in terms of we're talking about this is a new innovation, which is really exciting, but it's not the only innovation you guys are working on. What other sorts of brick innovations are you doing? Do you have a wider strategy, and what else are you working on that you can tell us about?
Yeah, I mean, innovation is one of our core values, as you would have seen right at the start of the presentation. So we're forever looking at ways to innovate brick. I mean, a big passion of ours is sustainability, and we're really big on trying to get these carbon neutral and even not carbon negative bricks out there. So we can really try and change that sort of cultural thing around brick. So in terms of other innovations, we've got our brick slips. So we're one of the few manufacturers now in Europe that actually produce brick slips, as opposed to cutting them from standard bricks. So we're minimizing waste there, and all the clay that's used in that manufacturing process is recycled in the closed loop circuit as well. So colors as well. And I suppose the top of our agenda is sustainability, Jordan. That's the big one for us at the moment, and these carbonated bricks. I
mean, I suppose that's the big one for everyone, isn't it? To try to work together to make that push towards net zero. So one of the other questions that's come in here is asking about key takeaways. So essentially, someone's written that their colleague couldn't join in today,
yeah.
and they're asking for a sort of snapshot that they could provide. What would you say are the top takeaways that they should be passing on to their colleague?
Okay, so yeah, depending on the individual, I'd definitely say from a design perspective, it comes down to detailing, making sure that we're getting the detailing correct when it comes to brickwork. And that's what manufacturers are there for. We can help with that. Basically minimizing any opportunities when the build gets to site where they're on site and they're going, oh, I don't know about this. So then that part of the facade is left exposed to the rain, which is then going to inhibit these other minerals to spread throughout the facade. So that's probably a big one. And basically protection. We need to be protecting bricks from getting wet and absorbing water to stop these minerals from being transported throughout the facade. I mean, and obviously it goes without saying that our coated bricks are going to give some element of protection for that as well. But yeah, that end video, the recap video, is available on our YouTube channel in full. So if anyone wants a quick recap again of what was covered today and try and understand a bit more about the science behind efflorescence, yeah, please head over to our YouTube channel for that.
And just on that point, we've had a few questions coming through about whether this will be available afterwards, just because there was so much detail that everyone really loved. And yes, it's available on demand via the same link that you used to get in here in the first place within half an hour of us wrapping up today. So you can go back and check anything out. If there is any colleagues you think should be watching it, you can direct them to the whole video or to the points that have just been flagged by Matt there. We also had some questions about whether the coating has any impact on the ability for reuse at a later stage. I know you covered off storage, and they can be stored in exactly the same way as traditional bricks, but in terms of them being demountable and reused, are there any implications for that?
No, none at all. I mean, it's benign. It doesn't have any impact on anything like that. It's a transparent coating as well. I'd say the only thing to be wary of in reuse, if you're using mixing coated bricks with uncoated bricks, there's going to be that element of water absorption from the ones that haven't been coated. So there might be a difference in colour as those ones absorb more water, because of the basically the fact that the coating would be on the bricks that have been coated.
We've also had a couple of questions come through about where in the process it's best to have, like the efflorescence process is best to take place. Is it best to take place with bricks before they're in the build, or, you know, to apply post construction?
I suppose ideally you want to be avoiding efflorescence altogether. But yeah, primarily
the prevention of I skipped a word there in my reading. Yeah, prevention of efflorescence.
Okay, so yeah, in the prevention of efflorescence, it starts on site really, and arguably, I suppose, as soon as the bricks are delivered and dispatched, just trying to keep them as dry as possible. If we do have a sort of culture within the industry of potentially stockpiling on sites as well, which doesn't obviously help the situation with bricks, and obviously it goes back to the initial question about availability as well. If we've got a lot more bricks on site that we need, then that potentially is making issues for the other people within the industry. So I would always say have on site what you need, and make sure they're covered and make sure they're stored off the ground so they're not absorbing any additional minerals from the ground as well. Yeah, in reality, I know it can be difficult.
I've also had a question come in about what's your view on pressure washing brickwork. I suppose particularly in that idea of, you know, trying to keep things as, you know, dry as possible.
Well, yeah, I wouldn't recommend it, and I know there's a number of like the BDA certainly don't recommend jet washing brickwork as well, because what you're doing is you're forcing the water deeper into the pores of the brick, so therefore it's going to take longer to come out. So yeah, I wouldn't recommend it personally.
Brilliant. Okay, and so then I think we've got just one more question from me, and then so the audience, please feel free to keep sending them through, obviously. But one question that I did want to ask you. So obviously you're a business that, you know, operates in this brick space. Are you seeing like a huge demand at the moment? You know, we touched on the shortage, but we've also heard there is huge demand. Do you find there's huge demand for your products at the moment?
Yeah, I mean, it's like anything within the construction sector. When people can't get hold of one particular product that they would like, then it tends to go further down the food chain, as I like to say. So yeah, we are seeing increased demand, but like I said at the start, we're trying to look after our strategic partners and those customers who have kind of been loyal to us, and the specifiers that are specifying our products, so that ultimately they're getting their builds built with our bricks.
Okay, brilliant. So I think that this is one where I think we're probably going to get quite a few questions directed to us to pass on to you at a later date, Matthew. Is that okay?
Yeah, sure. No, that's fine.
For everyone to absorb. So I think I might wrap it up there. But please do feel free to get in touch with us or with Matthew. His details are on the screen now, and we will share that. Thank you so much for your time, Matthew, and for, you know, sticking with us through the technical difficulties today.
No apologies from my side.
And so yeah, that's it from me. As I said, this session will be available on demand if you want to go back and check it out. It's obviously you know, really insightful and a great learning piece on this topic. Also, our session from this morning on material shortages is also available on demand, while our wider program of events is also at the same website. So all those links are on building design and housing today. So wherever you found us, you'll be able to find all this content again. So thank you so much, and goodbye.